So during this activity, you're going to be creating a maze. You're going to be making a game that involves a maze. In this activity, you'll extend your Python programming skills to create a maze. This is a very simple maze you'll be creating. So we start out with a base, and then we start adding walls, barriers. We start out simple. Real maze algorithms, though, I was looking over this, is more advanced than this. But in this class we're going to be doing simple to start off with. So first task, figure out how to produce a spiral, square spiral. Brainstorm and create pseudocode on how you would write an interactive algorithm. Interactive means that it has to be dynamic. To generate a square spiral. So it needs to be able to handle a varying number of walls. It suggests that you start from the center and work outward. Since you know how many times you'll iterate, use a for loop and the range function. I guess technically you could use a while loop too. On each iteration, turn your turtle and grow the size of your wall. What you're going to end up having is a few parameters. The main two are going to be the number of walls. So squarish shapes, 1, 2, 3, 4, 5, 6. For this case, and also a width of the wall, wall to wall, and implement it. So you'll need to have some configuration variables, the number of walls, the distance between the walls, in other words, the width of the path, the turtle's pin color to generate walls. By the way, configuration variables, as your program grows more complex, you'll be referencing these configuration variables instead of hard-coded values. These hard-coded values are referred to as magic numbers in code. In large programs, they can be hard to find, and their effect can be difficult to determine. So a literal variable value such as 5 or hello that is hard-coded into a program instead of being assigned to a well-named variable. When used in a large program, they can be hard to find. Their purpose can be hard to learn, and debugging makes them difficult. So if you have something that's non-trivial, so a random number, so for example 3.14, what number do you think that represents? Pi. You understand it as pi, but maybe someone else has no clue what the number is used for. It would be better because it has a well-defined meaning, and you'd probably use it multiple times over your code to save it as a variable. Now, if you have something as simple as A, B, C, D, E, F, and you're doing key presses, it's probably best not to save that as a variable because it's well understood. If you have in your code, if user press and you hard-coded in quotations A, quotation mark, it's very understood. That literally means the letter A. You don't have to create a brand new variable to store it. However, if you have something that's repeated, such as the width of the walls, that's going to be something that's used over and over throughout your program. It's a constant, but it's probably best to save it as a well-named variable. Let me show you some magic numbers. I don't know if you know this, but a lot of files, the very first bits in a file always have certain values. They're called magic numbers and can actually identify what file type. So you can look at the first few bytes and actually determine what file something is. This is known as magic numbers 2. If you ever look it up. Personally, I never heard the term magic numbers outside of file types. So I don't know how valid hard-coded.
Camera Newborn, come by the office, Camera Newborn.
So, first setup is draw this maze. Second is adding doors. So, once you get this built, run it, test it. Next thing is we're going to come up and add doors or pathways. So you'll transform your spiral into a maze. You will create doors, which is openings that connect different paths in the maze. And a real maze, doors are random and scattered out. This represents a fairly complex algorithm, and programming it will be easier if you do this in stages. So during programming, the best thing to do is do things. Don't start with the randomized difficult portion first. Do something static. Do something that's not random. Figure out how you can do it without randomizing it. Once you get it done and working, then you can come back later and make it random. So later on, you will modify your algorithm to place them in different random locations. But to start out, it's best to do it incrementally and do it by placing it in the same location. So brainstorm how you would add a barrier wall. In other words, a wall that is perpendicular to the maze and spans the width of the path. Think about the sequence of steps you need to do in each iteration. So place doors approximately 10 pixels from the edge of a wall. The door opening should be the same width as the distance between the walls. Let me show you an example. Oh, by the way, next week we're going to be starting your own custom game. And just like it's going to be the main project. Just like the previous main project, it's going to be quite advanced, detailed, very long game. Be thinking of the game you want to be making. Alright, so a door. This is so you'll start out by placing it on each same location in random spots. So what it means by door is this. So you have opening. And what it means by adding it in the same spot in each wall, just come over here and put it in the same spot, coming around it. So this is what it means by door or opening. Later on, you're going to make this random in the wall. but this is an opening path. And you put it in different locations. So in order to do this, so while you're drawing the maze, and when you add a door or an opening, you're going to need to stop drawing, move a certain distance, and then resume drawing the remaining distance. So keep in mind that you're going to need to subtract. So you have a total distance here. You're going to go some portion of a distance, and then you're going to stop drawing for the width, and then you're going to go to remaining distance. So again, it's probably best if you keep separate versions of your program during the development process. Because if you run into errors, you can look back at your previous code and see if somewhere you changed something to make an error. Or if you totally screw up your code and you have to start over, you don't want to start over from the very beginning. You just want to start over from the previous step. So if you completely screw up your code during adding doors, you don't want to come over here and have to refigure out how to draw the maze. Next, we have barriers. So barriers are going to be blocking the pathway. So next, you need to add barriers or closed off pathways. Again, to keep it simple, you'll be placing the barriers in the same location. So here they did it like this. Here's the openings. Here's the blocked ways. So at the end of this section, your maze is similar to something like this. They added four doors for each wall going out, and they did this. Brainstorm how you would add a barrier wall. In other words, a wall that is perpendicular to the maze wall and spans the width. So maybe, again, you have to come up with your own idea. Maybe while you're drawing, you randomly stop somewhere, go up the width of the pathway, then go back, and then continue drawing. Maybe is a good way. So you just draw. So as you're spiraling outward, you stop at some random location, maybe here. You quickly come over to the right, then you come back, and you continue drawing. That could be one way of doing it. So when you test your program, you will see that the innermost walls of the maze are not long enough for both doors and barriers. So what it's saying here is maybe you shouldn't add walls and barriers to the innermost walls, because if you look at your maze here, if you were to draw a barrier, notice it doesn't actually do a barrier here, or if you do a barrier here, it doesn't actually block off the path. Or if you do something like this, again, this doesn't do it. So maybe skip the innermost for barriers. Also, if you try drawing a door, maybe you do like this. This isn't a full door. So write an if statement so that the first four walls are not drawn. So when testing, you see that the innermost wall of the maze is not long enough for both doors and barriers. It says actually to remove. How to do that? Interesting. It suggests to actually remove like the innermost wall. Let me look at the official. Why? I don't know why. Looking at the official solution at this point, they have it. They have this. So I do remove the innermost. It also looks like they count a wall as this. So looking at this, let me go back to the spiral. So 1, 2, 3, 4. It looks like they count this as 4 walls like this. So 1, 2, 3, 4. Looks like they're removing like that. Yeah. But then that looks really, really weird. I'm confused on why they chose to do that, but that's how they chose to do it. Why not start the for loop at 4? Because the walls would not grow and scale. So basically add an if statement so that the first 4 walls are not drawn, but you still move it. The turtle's still gonna move and trace them out. You just do pin up. Once you have that, you're gonna go back and change and make the doors and barriers random. Right now it's just drawing. And toward the end of the program, you're going to create a turtle that's going to go race through this. So randomize the door. Again, there's an advanced version. Let's see. Move forward. G. Alright, looks like you don't have to worry about collision detection though. The official solution doesn't have collision detection. The advanced solution does suggest that you make collision detection. I might have that. Looking at how difficult it is. Oh, that's actually super easy. Yeah, that's super easy. You can, after painting, there's a function, I'll show you how to do it when and get it. We are going to have collision detection on this. There's no reason not to make it to where when the turtle hits a wall, it dies. So let's go down here to the advanced thing. So your maze is nearly complete. As a last implementation, you can choose different features to customize the maze. Solid walls, meaning that if you so omit doors on the exterior wall so the turtle can escape. We are going to have that. Well, that's how normal mazes are. It's like you can't leave and go out. Restart the game. I want that in it. A timer to report your score. So that's the score feeding to it. A start and stop screen. Again, it's just a start. We've already done that. You have a button. It says start. You click on it, and it calls your start game function. Vary turtle speed. Won't need to do that. That's optional. Add buttons to let. So you have forward that make it increase your speed. Multiple turtles. Oh goodness no. This one's optional. You can have variable speed. I'm also adding that you need to check for collisions. I will help you on that. As you have to look up the code. Basically, what you do is we have our turtle object, and you get the turtle's current position, and you see if it. Then you ask on canvas, what color is this pixel? You get it? So you come over here and you get its current position, and you ask, what color is this pixel? Is it black? Well, obviously the turtle is inside a wall. Is it white? Or wherever the background color is? Well, obviously the turtle is not in the wall. I will leave it up to you whether or not you want to make it the game stop and print out, I'm sorry, you crashed into the wall. That'd be the easy case. Or back up and make it so the user can't crash into the walls, but they can they can't go through the walls. So you can either make it where the game ends whenever they hit a wall, or make it to where they just can't move through walls. What else? So today is Wednesday. So I'm literally, my plan is, for most of all, so for this project too, like just like the last one, my plan was give you time in class to work on it. This is like, no. But it says this is supposed to be 3 days, so today, tomorrow, and Friday. I probably add in. Oh yeah, I'll be due Monday. It won't be due Friday. So my plan is, so tomorrow and the next day you can work on it in class. There won't be any videos posted. Yeah. If there's something I need to comment on, I'll comment it and make a video on it. But for the most part, this is going to be you guys working on it, follow the instructions, read through all the steps. If you want me to run it and see if it looks good, you get stuck on something, copy and paste it. I need to come up with a write-up for this, which I'll try to do this afternoon. Well, so in programming, a lot of times you look up other people's code, and if it's in the free and open domain, you can use their code. It is ethical to comment, this was copied from so-and-so source. There are also, we have in the programming world, licenses. So, GNU license. It's called General Public Use License. Basically, if you find some code online that has this license on, you are 100% free to use that code. Copy and paste it into your code. However, you must also copy and paste the license into your code. So basically, let's see if he has it. You have to copy this paragraph into your code. You may modify your copy or copies of the program or any portion of it, thus forming, or you have to somehow link that this code is subject to GPL version 3, or whatever. So in order for your code to be legal, you have to copy and say that you're following the general purpose, general public license. This, which means if anyone else, what that means is you can take the code and sell it, but you do not have the rights to the code and to any portions that you copied or modified. Which means someone else can come and get your code and use it too, and they can sell it. But it only applies to, and I don't know. There's so many. Some of them, I don't know if GPL does that. You have to read it. There are so many licenses. Some of them are completely 100% free, meaning that you don't have to include the any license with it. You can sell it private. Any questions? I'll relook at this and see if there's anything else. The only thing is that you're going to have difficulty, and I'll make a video on it, is you're going to have the checking to see if a collision occurs. But this is actually, you're actually checking to see a line you previously drawn. So we've been doing the get screen. I'll actually paste. And show you the code. So this is the code for detecting for collision. So you have your when object. We've been doing the screen, but here we can get the canvas. That's what we've been painting on. And then we can do something called, so when we get the canvas, we save it to a variable w in canvas. And then we can do item c get. And let me look up what items were. They also had this. So basically, find all the pixels in using these margins or the size. So basically negative, so the top left corner, so this would be, this is starting at the top right. No, this is the bottom right coordinates, and this looks like the bottom left coordinates. It's because margin is the width of the screen. Looks like. Anyway, you need to figure out what this does. Look it up. So it takes 3 values, a number, or 4 values. This is all the pixels. Then it does this with 0. I don't know exactly what this does. But anyway, this is how they're getting. I'll look at this more in detail and show you how this works. But all you have to do is now it gets item color. Is this equal to black, for example? If it is, collision. Else, menu. I will look more at this code and make a video on it. I'll create a simple program that has a line and have a turtle moving forward and show how you can do it and better explain it. You can create a function. Oh, you don't have to. So, okay, think about this. This is the good thing about program. So why do you want to hop back? All right. So I'm going to move this pixel this amount of space forward, right? Before I move, I can ask, is this square in front of me black? If it is, a collision would occur. Don't move at all. Or you can do what you're saying. Move forward. Check to see if a collision happens. If it is, move back. Or what you could do is check to see if a collision will occur before you even move. If a collision occurs before you move, then so you figure out what your new position will be, your new coordinates will be, and before you actually type go to new coordinates, check to see if new coordinates would cause a collision. And if it would cause a collision, don't move. Make sense? No, because what would happen is when they get to the wall and they press right, the thing won't move. If they press forward, they start moving forward. If they press right again, it doesn't move. And if they press left, down, right, and as soon as they hit the wall, they stop moving. What you're suggesting is have it to where boop, boop, boop. I mean, you can do it either way you want. Mine does sound easier. And also, when you actually play maze games, do you see the bouncing motion of the player when sliding in the walls? Here's the code word. So, you don't like doing plans to that code. So, whenever we do the team-based project, imagine Again, sure. Yeah. But so you're going so you and your teammate. Well, obviously. So I'll never learn second and third period. Anyway, but so you've been writing all the logic by yourself. Now imagine where you need to design half the program, and while someone else is designing another half. Well, here's why pseudocode is very good. And you can create blank functions, and you tell them you need to create a function that does this. And but you have to figure out the pseudocode so you can write your version, and you just assume that that eventually you're going to get that function completed. Write your entire program using a function that does this. And then all you have to do is once y'all meet up, copy and paste this function into the program, and your code should instantly work. Assuming his function has a it's very important you know how on computer science how to work with a partner because
Knowing that they know what they're doing. But
Oh.
again, school would let me believe every other student has
Oh.
no idea how to do it.
You have to also assume your partner is going to be an idiot and completely mess up his code. And what's the reason why you add tons and tons of errors? You program correctly, it should pop up. This error was due to a mistake someone else did. Go to his code and fix it. So will you be gone tomorrow? Oh, also, there is a chance that your maze will be unsolvable. That's fine. We'll just because we're generating randomly. If you're curious, only got a minute. Maze generation. Yeah. Images. If you're curious to how real mazes are generated, they use depth. It's not loading. It's not loading quick enough. Oh.